Good afternoon, people.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon.
afternoon, sir.
Good afternoon, everyone.
गुड आफ्टरनून सर.
Good afternoon, जी. Good afternoon. क्या हाल चाल?
ठीक है सर, आप कैसे हैं?
बढ़िया. बढ़िया. All good. Last class छूट गई टाइम से?
Yes.
Okay. That means we are ready to start. क्या टॉपिक चल रहा था? इको साउंडर. Is that correct?
यस सर.
क्या क्या कर लिया इको साउंडर में?
Sir, types of transducer provided थे आपने last.
Okay. Last में we have done types of transducer. So we have seen the basic principle, which is basically working on the principle of reflection of wave. There is a transducer fitted at the bottom which transmits the signal vertically downwards. The signal is reflected back. Time is calculated. Time between transmission and reception. Total distance traveled by the wave, which can be calculated by speed into time. Speed of the wave through the water is 1500 meter per second. For salt water, we know. So C into T is the total distance traveled divided by 2 is the depth, UKC. If you want the draft, if you want the water depth, then we add the draft. The static draft of the ship should be added to the UKC in order to get the depth of the water. So that was the basic principle. The transducer also we saw the block diagram also, how the echo sounder is working. With the help of a block diagram, we explained that. Then types of transducer में दो तरीके के हमने देखे, इलेक्ट्रोस्ट्रिक्टिव एंड मैग्नेटोस्ट्रिक्टिव. दोनों का एडवांटेज डिसएडवांटेज भी देखा. Electrostrictive works on the principle of piezoelectric effect of a crystal. Magnetostrictive transducer works on the principle of magnetostriction. When a piece of iron or piece of metal is magnetized, the size is becoming small because of all the molecules are getting arranged. There is cohesion. Cohesion is force between two bodies, or intermolecular attraction basically is cohesion. So because of cohesion, the whole of the bar of the metal becomes small and it vibrates when supplied with AC signal, alternating current. Now the basic principle that we have seen, total distance divided by 2 to find out the UKC. How is it happening? The echo sounder does not have any calculator as such. ऐसा नहीं है कि उसमें नंबर्स डालते हैं कि इतना टोटल डिस्टेंस हुआ 300 मीटर्स डिवाइडेड बाय 2 तो डेप्थ 150 मीटर है, ऐसा नहीं हो. बट बाय द डिजाइन ऑफ द रिकॉर्डर ओनली वी अचीव दिस गोल. जो रिकॉर्डर होती है उसको इस तरीके से डिजाइन किया गया है कि हमें ये डेप्थ मिल जाती है, ये कैलकुलेशन भी हो जाता है. So how is it happening? That we are going to see on the board, where we are going to discuss a recorder. Recorder of the echo sounder is the device which you actually see as a echo sounder in the bridge. Of course, you have seen most likely the digital types. There is a screen on which the depths are displayed either in number और नंबर के साथ प्रोफाइल भी आती है कि इतने मीटर 60.3 मीटर्स का डेप्थ है और उसकी ग्राफिक रिप्रेजेंटेशन भी हो रही है सी बेड की. So right now we are mostly using digital displays. But before this, and parallelly sometimes maybe now running also, there is something called electromechanical system, which is there are moving parts. Recorder has got moving parts. कुछ मैकेनिकल चीजें हैं, कुछ इलेक्ट्रिकल चीजें हैं. So that is another type of record, what we call the echograph. In fact, both of these recorders we said, electronic and electromechanical, are same thing, basically echograph. Electronic, electromechanical. So now we are going to understand how this echo sounder recorder works. अगर इस चीज को हमने बढ़िया से समझ लिया तो इसके साथ की बहुत सारी प्रॉब्लम्स जो आने वाली हैं, प्रॉब्लम्स इन द सेंस क्वेश्चंस आने वाले हैं, दैट विल बी ऑल क्लियर. लाइक व्हाट आर द एरर्स ऑफ इको साउंडर. तो बहुत सारी चीजें हैं जो इस फंक्शन से समझ में आता है. व्हाट आर द कंट्रोल्स ऑफ द इको साउंडर, तो इस फंक्शन से ही समझ में आता है. What kind of correction should be done to the echo sounder reading? इसी फंक्शन के समझ से समझ आता. So pay proper attention, try to understand how the system is working. Going to the board, let me set up the camera. All right, board visible? Yes, sir.
Yes, sir.
Okay. So what we are talking about is an echograph. And what actually we are discussing is electromechanical type, which is in the syllabus. But the digital system also works on the same principles. सिर्फ इलेक्ट्रॉनिक्स हो जाती है वहां पे, मैकेनिकल सारा हट जाता है, but principle remains same. Now, what we have is a roller. Basically a cylinder which is operated by a motor. That means ये घूम रहा है. The roller can be turned by the help of a motor. There is another slot on which there is a roll of paper. There is a roll of paper. इस पेपर में से, इस रोल में से पेपर खींचते हैं और इसके ऊपर लपेट देते हैं. So this paper is going over this cylinder. So what you see right in front is a plain sheet of paper. When this is turning, of course the paper will be released from this side and it will be taken over by this side, on the right side. So paper is moving on this axis, left to right, x-axis we can see. Now we have two discs or pulleys on which there is a belt. These pulleys also are operated by a motor. So when this is rotating, the belt also is rotating like this. On the belt, there is a metallic element which is installed on the belt. Is called stylus. So this is the belt This is the stylus. These are the pulleys. One of them is motorized. So as you can see, when the motor operates, the belt will be going like this, and with the belt, this stylus will also be moving like this, or correct? ये जो stylus है वो इसके साथ साथ चलता रहेगा ऐसा. So the stylus is moving on this axis, which is y-axis. So paper is moving on x-axis and stylus is moving on y-axis. Remember the block diagram of the echo sounder? The ship was transmitting the pulses. This is, let us say, whatever pulse 1. In the recorder and the transmission of the pulse from the transducer, these two are synchronized in such a way that when it is just starting, the stylus is at 0 point. 0 mark पे है ये जब ट्रांसमिशन हो रही है. अभी शुरुआत होने वाली है, उस समय ये यहाँ पे था. Let us now also consider that this paper roll is something like 10 inches. And on this 10-inch paper, the marking which is there is 0 to 50 meter. The scale on the echo sounder is 0 meters to 50 meters. So 10 inches is equal to 50 meters. That means 1 is equal to how much? 5 meters. 1 inch is equal to 5 meter, 2 inch 10, like this. Of course, we know now that the pulse travels to the ground, to the seabed, and it is reflected back as an echo. It is received here, amplified, converted into electrical signal and amplified, and is given to the recorder. Is it correct or not? Block diagram.
Yes, sir.
This signal is actually given to the stylus. जो ये electrical signal generate हुई echo से, that is given to the stylus. The stylus on receiving this, चूंकि ये metallic होता है तो इसका tip गर्म हो जाता है. This tip is becoming hot. Whenever there is a signal coming, it becomes hot. Instantly hot होता है और फिर cool off भी होता है. So this incoming echo makes the stylus warm hot. Now what is the significance of that? Let us say the depth here was 50 meters. The seabed depth is 50 meters. The signal when travels from here to the seabed, how much distance traveled? Going down, how much distance traveled?
50 meters.
And then going back, what is the distance traveled?
So total 100 kil.
Total 100 meters. Total 100 meters. 1 second, I'm looking for something, just 1 second, hold on. Okay. So, total 100 meters. If on the recorder there has to be marking of this 50 meters. Where on the paper should be the marking?
Sir, last में
Last में, something closer to this should be the marking, correct?
yes sir.
So the pulse was traveling 50 meters, coming back 50 meters, total 100 meters. By then, because the motor was operating, the stylus is going down, it must be reaching here. When the signal is converted and given to the stylus was at this point. The stylus becomes hot and this heat is transferred to the paper here. This is a special type of paper which, when heated, becomes black. The stylus is becoming hot. The stylus is touching the paper. The heat is transferred to the paper. The paper becomes black. Not out of the world paper. Very normal kind of paper which you see in ATMs also. When paper like this is heated, it becomes black. When heated, it becomes black. It is thermally coated paper. Whenever there is heat, it becomes black. So similar kind of paper is there for the echo sounder. When it is becoming hot, there is black marking on this. That means this scale was 1 inch is equal to 5 meters. From here to here, 10 inches was 50 meters. So in the time, pulse has gone 50 and come up 100. When it has done 100 meters of distance, the pulse traveling at 1500 meter per second, remember. On the scale, the stylus has moved how much of distance? जब ये 100 चला, तो stylus कितना दूर चला है? Scale पे?
10 inch.
Meter में? You are right, 10 inches. But in meters, scale?
50
50 meters, क्योंकि यहाँ पे 0 है, यहाँ पे 50 है. So on scale it has done 50 meters when the signal has traveled how much?
100 meters.
So what is the relationship between the speed of the acoustic wave in the water and the speed of the stylus here? जितनी देर में ये 100 मीटर चला उतनी देर में 50. So what is the relationship between the two speeds?
0.5 का ratio है sir.
1:0.5. और अगर बोले तो 1:2. Basically what? The stylus is moving at half the speed of C. If this is 1500 meters per second, then the stylus moves at the speed of 750 meters per second. That means ऊपर से नीचे आने में 1 सेकंड नहीं लगा होगा. 85 मीटर तो चला है. It must be moving faster. So this gives us an understanding that the stylus is rotated at a constant speed, which is half of the speed of the acoustic wave through the water. When it travels like 100, example के लिए, when it travels 100 meters, only traveled by this is half of that, which is 50 meters. So because of this speed synchronization, have we got the effect of C into T divided by 2? Did we get it here? जब 100 मीटर चलती है तब 50 मीटर चलता है ये. तो डिवाइडेड बाय 2 हो गया यहाँ पे या नहीं? So that principle C into T by 2 is not a calculator. It is just managed by synchronizing the speed of the stylus, which is rotated at half the speed of acoustic wave through water. Through the water, 1500 meters per second, the stylus moves at 750 meters per second, such that when it travels 100 meters, it will travel 50 meters on scale. If it travels 200 meters, this will travel 100 meters on scale. So divided by 2. So do we now understand how an ecograph is working?
Yes, sir.
Very good. So this was the range scale that we had taken, was 0 to 50 meters. The top part is indicating 0, the bottom part indicating 50. When we were measuring depth of 50 meters, this 10-inch of paper was traveled in how much time? If the wave is traveling 100 meters, तो जितना 100 meters चलने में time लगेगा, उतने ही time में ये यहाँ से आ जाएगा. So tell me, what is the time required for traveling 100 meters by the acoustic wave? Calculate करके बताइए.
Point 006.
0.006 you said. So in 1 second or 1500 meters in 1 second, that means 1 meter in 1 by 1500 meters. That means in 100 meters, it will take this. That means 1 by 15. How much is 1 by 15?
Point 006.
0.006. So 0.006.
0.06.
0.06. Okay. So time taken to travel from here to here is 0.06 seconds. That means यहाँ से यहाँ आने में 0.606 seconds लगा. Now suppose I am changing the range scale to 0 to 100 meters. That means earlier which 10 inch was 50 meter. Now that same 10 inch is now 100 meters. Is that okay? Because now it is reading 100 meters here. So 10 inches is equal to 100 meters. Has the scale reduced? Small scale हो गया या बड़ा large scale हो गया ये?
Large scale हो गया.
Large scale हो गया. Think of the chart. Large scale chart में क्या होता था और small scale chart में क्या होता था?
सर स्केल छोटा हो गया, उसका मतलब मेजरमेंट वैल्यू वो ज्यादा हो गई, ये कहने का मतलब.
Measurement तो scale छोटा हो गया ना?
Yes, स्केल छोटा हो गया, ज्यादा वैल्यू मेजर कर सकते.
Small scale रहा. Okay. Now suppose that you are now measuring, let us say 100 meters. That means the signal will go and come back. 200 meters will be the time, and the marking should be again at the bottom here itself. That means this time the stylus takes time which is required for 200 meters at this speed to travel. That means will it be twice the time or not?
Yes, sir.
अगर twice the time it is taking, मतलब ये धीरे चलेगा. पहले जो जल्दी जल्दी चल रहा था अब धीरे धीरे चलेगा क्योंकि डबल टाइम ले रहा है। ज्यादा टाइम इतना ही चलने में ले रहा है, मतलब धीरे चल रहा है ना।
Yes, sir.
Yes, sir.
मैं
Yes,
एक
sir.
जगह से दूसरी जगह जाता हूँ, मैं अपने यहाँ से ऑफिस जाता हूँ, मैं तेज चलता हूँ तो जल्दी पहुंचता हूँ, ज्यादा टाइम ले रहा हूँ मतलब
धीरे चल रहा हूँ।
Slow में चलना है sir, slow.
तो इस केस में स्टाइलस धीरे हो गया, इस केस में फास्टर था। अगर मैंने दूसरा स्केल लिया तब तो ये और 4 टाइम्स हो जाएगा और धीरे हो जाएगा।
Yes, sir.
यस सर।
सो एक तो ये हुआ, जैसे जैसे ये रेंज स्केल बोलते हैं इसको, नॉर्मल रेंजिंग, देयर इट इज स्टार्टिंग ऑलवेज एट 0 and the upper range is increasing 50, 100, 200 etc etc। इसके साथ हम देख रहे हैं कि स्केल का स्टाइलस का स्पीड भी चेंज हो रहा है, लोअर स्केल्स फास्टर स्पीड, जैसे जैसे रेंज बढ़ रहा है वैसे स्पीड कम हो रही है। बट along with that there is another thing which is happening, and what is that? Another observation is that the 10 inches of paper, पहला 1 inch was 5 meter, अगले स्केल में हाफ इंच इज इक्वल टू 5 मीटर, और ऊपर रेंज में इतना मतलब 5 मीटर। अब मैं यहाँ पे पढ़ाई कर पाऊंगा, रीड कर पाऊंगा 5 मीटर?
No, sir.
तो as the range is increasing, the resolution of printing becomes poorer and poorer because the range is more, the graduations become smaller and smaller। जो पहले 5 मीटर इतना था तो मैं 1-1 मीटर देख सकता था, अब जब रेंज बड़ी कर दी तो 5 मीटर इतने में आ गया, मैं इसमें 5 और 6 और 7 और 8 कहाँ रीड कर पाऊंगा? So this one is ranging, normal ranging in case of the echo sounder. And there is an associated problem. What problem can you identify with ranging? What is the problem in this ranging?
ज्यादा रेंज पे एक्यूरेसी कम हो जाएगी।
वेरी गुड, रेंज पे एक्यूरेसी कम हो जाएगी। एक्यूरेसी कम हो या नहीं मैं पढ़ नहीं पाऊंगा, एक्यूरेट है भी तो मैं देख नहीं पाऊंगा कि क्या है। Resolution becomes poor, the graduations become closer to each other, we cannot read it। So in normal ranging this is the problem, resolution। और उसमें भी अगर रिकॉर्डिंग थोड़ी सी ऊपर थोड़ी सी नीचे हुई तो बहुत बड़ा डिफरेंस हो जाएगा, क्योंकि छोटा सा डिस्टेंस इज अ मोर डिफरेंस, दिस ग्रेजुएशन ऊपर नीचे की थोड़ी सी प्रिंटिंग विल मेक द एरर मोर एम्प्लीफाइड। So the problem of ranging is solved. The solution for this is something called phasing। जो रेंजिंग की प्रॉब्लम थी, this one, for that we have a solution called phasing। Now what is phasing? phasing में क्या होता है? तो नॉर्मल रेंजिंग में आपने देखा that the range scale was always starting at 0, range was always starting at 0, but in phasing what happens? The range scales are something like this, 0 to 50, next one is 50 to 100. Next one is 100 to 150, and then 150 to 200. Between upper and lower range, you can see that the difference is increasing. पहले 50, फिर 100, फिर 150, फिर 200. What about this? Difference is 50. What about this?
Same.
This also 50. This also 50. That means in case of phasing, that 10 inches of paper is always representing 50 meters. Is that right or not? मैं ये रेंज सेलेक्ट करूं तो भी 50, ये रेंज सेलेक्ट करूं तो यहाँ पे 50 हो जाता है, यहाँ 100, अगेन 50, अगली रेंज सेलेक्ट करूं तो ये 100, ये 150, अभी भी 50. तो यहाँ से यहाँ का डिस्टेंस तो सेम है all the time. That means stylus will be constant or not?
Yes, sir.
तो phasing में stylus is rotating at constant speed. In phasing, the stylus is rotating at constant speed because upper and lower range, the difference is always the same. Now, how is it done कि ऊपर में 100 दिखा रहा है, यहाँ 150, ऐसा कैसे हो गया? So not only this is done, stylus is rotating at a constant speed. सिर्फ यही नहीं होता, इसका डिजाइन भी चेंज हो जाता है. The echo sounder recorder is now different, not what we have seen so far. So how is it different? We still have that same drum, same paper. The same belt and the same stylus. The shape is transmitting signal. When it is transmitting the signal, it is synchronized in such a way that it is at 0 when the transmission is just beginning. Just शुरू हो रहा है, उस समय ये 0 mark पे था. So this is the same condition as it was in the ranging case. 0 to 50 के range में phasing में भी यही होता है. No issues at all. But phasing वाला device जो है, the device which is using phasing, there are sensors placed around the belt. Let us say 1, 2, 3, 4. These are sensors placed around the belt, and there is a magnet which basically triggers the transmission of the pulse. जब रेंज हमने 0 to 50 सेलेक्ट किया, उस समय सेंसर 1 is in action और ये सारे आउट ऑफ सर्किट होते हैं, इनका काम बंद हो रहता है, ये सब बंद रहते हैं. This is in operation. When the magnet is passing near the sensor, at that time the stylus is here, the transmission is taking place. When transmission happening, stylus at 0. When the signal goes 30 meters down, of course this will go 15 meters. 15 मीटर पे जाएगा या नहीं? Stylus will move 15 meters when the signal goes 30 meters. Right or not?
Yes, sir.
Yes, sir.
Why? Why? ये 30 तो वो 15. क्यों?
Sir, half distance travel करेगा. Total 60 करेगा तभी वो 30 पे आएगा.
Exactly. Very good. Very good. That's exactly what I wanted to hear. Because it is running at half the speed. जब ये 30 चलेगा तो ये 15 चलेगा. जब ये 30 वापस जाएगी तो ये 15 और आगे जाएगा और 30 मीटर्स पे यहाँ पे जो रिसीव सिग्नल आई स्टाइलस को दिया, स्टाइलस ने ब्लैक मार्क कर दिया यहाँ पे. So the first range is exactly the same as it was in ranging. But when the range is changed over from 50 to 100, this is the range now. Then this is taken out of the circuit and this is in action now, sensor 2. अब जब ये मैग्नेट यहां पे होगी तब ट्रांसमिशन होगा. So the pulse will be transmitted when the magnet is at this place. तो मैग्नेट को यहां पे आना पड़ेगा ट्रांसमिशन करवाने के लिए, राइट और नॉट?
Yes, sir.
मतलब हमने मैग्नेट को पीछे किया तो ये स्टाइलस जो थी, जो यहाँ पे थी, वो अभी पीछे जाएगा या नहीं? यहाँ पे आ गया या नहीं स्टाइलस? क्योंकि
Yes,
दोनों बेल्ट पे ही है, दोनों बेल्ट पे ही लगा हुआ है. तो मैग्नेट पीछे तो ये भी पीछे.
Yes, sir.
Yes, sir.
दिस डिस्टेंस कितना पीछे है? It is equal to 50 meters, which is the lower range. ये नॉर्मल स्पीड जो 750 के स्पीड से ये अपने 0 पॉइंट से कितना पीछे है? बाय द अमाउंट ऑफ द lower range of this. Now when the magnet is here, the transmission takes place. It is now starting, magnet is here, stylus is at this point. Let us say the depth is 50 meters. तो जब ये 50 meters जाएगा पल्स, तो ये स्टाइलस 25 meters आएगा या नहीं? जितने देर में ये 50 चला उतने देर में यहां से 25 चला जाएगा या नहीं?
Yes, sir.
Yes, sir.
जब ये और 50 जाता है तो ये यहाँ पे 0 पॉइंट पे आ जाएगा या नहीं? 50 + 50, तो यहाँ से जो पीछे 50 था ये 50 चलेगा जब ये 100 चलेगी. सही है या नहीं?
Yes, sir.
So when the signal is received here and it is given to the stylus is at 0 point. That means 50 meters ka mark is happening at this place. Top of the paper we are getting recording of 50 meters here. So this is now 50 meters. Supposing that you are reading 100 meters. तो जितने देर में ये 100 जाएगा, स्टाइलस यहां से 50 आ जाएगा, टोटल 100 जाना 100, तो इसका 50 यहाँ पे,
Yes,
फिर
sir.
वापस 100 जाना, तो इतने देर में वापस 100 जाएगा, तो ये 50 नीचे आएगा, मार्किंग हो जाएगी यहाँ पे 100 meters की मार्किंग at the bottom. So do we have the same range scale being shown on the paper?
Yes, sir.
50 meters on top, 100 meters at the bottom. 10 inches of paper is equal to how much? 50 meters. That means 50 यहाँ पे, 60, 70, 80, 90, 100. उतना ही गैप जो कि पहले होता था 0, 10, 20, 30, 40 and 50. वही गैप, वही स्केल, all maintained. Similarly, when the range scale is changed again, is let us say 100 to 150, then what happens? This is out of action and this one comes into action. Sensor 3 is in action, all other are not there. Now for that, magnet has to be here at this place. Then only the transmission take place. So the pulse is starting when the magnet is here at sensor 3, but since stylus was fixed on the belt, the stylus will be somewhere here. Will it be or not?
Yes, sir.
तो from zero line से कितना पीछे होगा stylus?
100 meter.
Very good. So या तो हम ये बोले कि स्टाइलस पीछे है, या ये बोले कि ट्रांसमिशन आगे हो जाती है, या तो ये बोल दें कि एडवांस हो गई, या ये बोले कि स्टाइलस पीछे है. तो in writing, when we write answers, we say the transmission is advanced. The transmission is advanced before the signal, before the stylus is coming to 0 point. The signal is already transmitted. Pulses are advanced by an amount equal to the upper range of previous range. What we said? 0 to 50, 50 to 100, 100 to 150. In this case, it was synchronized at 0. 0 pe transmission. In the next range, it was behind by how much? Upper range scale of the previous range. इस range में जब आते हैं तो कितना एडवांस कर दिया? Upper range of the upper limit of the previous range. तो 50 से पीछे कर दिया इसको, या 50 से आगे कर दिया, ऐसा बोलेंगे. When we are selecting this range, then the stylus is here. पहले इतना ट्रांसमिट कर दिया. कितना पहले ट्रांसमिट कर दिया? Again, upper limit of the previous range. So इस रेंज में upper limit of previous, इस रेंज में upper limit of previous range. That is how the advancing is done. In this case, the stylus is rotating at constant speed. The graduations are always same. The resolution of the printing is always same. What do you say? Are we good?
Yes, sir. Good.
So what we did was echograph, and we did ranging and phasing. These are the two things we did. Now coming to the more closer aspect of echo sounder, or more practical aspect of the echo sounder. When the ship is running, when the ship is sailing, not running, the echo sounder is recording a depth. But it may happen that at the 0 line there can be dark lines like this. 0 line पे बहुत dark line आएगी. Depth तो यहाँ पे है, लेकिन 0 line पे ऐसे है. और हो सकता है कि इधर उधर और भी प्रिंटिंग सब आती रहे. So of course this is the depth indication, but this is something that I don't want. Why should it be there? Or these dots and here and there signals coming or printing happening, these are not what I want. I just want my recorder to give me the depth, but on the screen we can see lot many other things also. All these are result of noise. Other signals which are being produced here or results shown on the screen are because of the noise. जब आप गाना सुन रहे होते हैं, बिजली कड़कती है तो खड़खड़ करता है आवाज. आउटपुट साउंड है तो साउंड में उल्टे सीधी आवाज है. यहाँ पे आउटपुट प्रिंटिंग है तो प्रिंट में आउटपुट गड़बड़. So there can be various reasons for noise. The noise can be man-made or shore one, can be because of animals. Animals matlab dolphin or whales, they are producing sound waves. They also do echo sounding. Whales and dolphins, also some other kind of killer whales, they all use echo sounding for finding out food. वो इधर उधर सिग्नल भेजते हैं, जिधर से टकरा के वापस आती है, बोलता है खाना उधर है, तो उधर को जाते हैं. We have learnt it, this principle we have learned from the animals only. So animals also produce sound waves to find out their food, which may also be picked up by the transducer, our transducer. There can be receiver noise also, जो electronics है उसके चलते भी हो सकता है. Engine noise can be picked up. So there can be various sources of noise. We will just talk about two of them. What we term as cross noise. And also something called aeration. Both of these are producing similar kind of effect. Cross noise and aeration both will produce effects like this. Others are produced by other reasons, like what we said, the engine noise or fish or shore noise, etc., etc. They are produced like this, but mostly these two will be producing results like this. How come? कैसे होता है? So we know that there is a transducer for transmission, there is a transducer for reception. Sometimes same, but sometimes separate. When two transducers are used, one for transmission, one for reception, the signal is transmitted from here. The signal should go down, hit the seabed, and come back as reflected energy. But remember that when the signal was transmitted, is it not going to get picked up by this? बगल में कान खुला हुआ है, यहाँ पे बोल रहा है, तो इसका इंतजार करेगा कि नीचे जाके आएंगे तब. जैसे ही होता है तो ये रिसीव करता है. इमीडिएटली ट्रांसमिशन, इमीडिएट रिसेप्शन. साइड में तो बगल में तो है, तो जैसे ट्रांसमिट करता है वैसे रिसीव होता है. Remember, on the recorder, stylus was here at 0 point. और जैसे ही ट्रांसमिशन हुई, रिसेप्शन हो गया, तो ये कहां पे होगा? स्टाइलस कहां होगा इस समय?
जीरो पे ही हो.
जीरो. और बहुत स्ट्रॉन्ग सिग्नल भी आ रहा होगा, एंड वेरी स्ट्रॉन्ग सिग्नल इज गिवन टू द स्टाइलस, क्योंकि रिसीवर इमीडिएटली एकदम बगल में है, जोर से सुन रहा है और नजदीक में जीरो लाइन पे ही है. तो यहाँ पे ये हमेशा मार्क करता चलेगा कि नहीं डार्क?
Yes, sir.
बाद में जो सिग्नल जाके आ रही है वापस, वो तो आएगी, डेप्थ आएगा, लेकिन बार बार ये रिकॉर्ड करता रहेगा या नहीं? Every pulse is producing this effect. So at the zero line, there can be dark marking here. So this is a problem called cross noise. यहाँ से बार बार उस तरफ को चला जाता है. Cross noise is happening, results into a dark line near the zero line. What could be the solution? What could be the solution? When the transmission is happening, what if we cut down the receiver? जब ये बोलना शुरू करे, उस समय रिसीवर को दबा दिया, सुनने के लिए कान ही बंद कर लिया, तो अब तो सुनाई नहीं पड़ेगा, ये चल पड़ी है, दूर जा रही है इधर को। अब जब यहां से आ रही होगी उस समय इसको हमने खोल दिया कि हाँ आप बोलो। तो whenever there is a transmission, this gain is reduced to 0. The amplification by the receiver is put to 0. मतलब कान बंद कर लेता है, जैसे ही ट्रांसमिशन होती है कान बंद। फिर जब ये निकल पड़ा उसके बाद कान खुला कि अच्छा ठीक है अब आओ, तो आती हुई इको को रिसीव करता है, लेकिन ट्रांसमिटेड डायरेक्ट वेव उस समय रिसीवर इज ऑफ। So basically what we are doing, we are increasing the gain or reducing the gain. During the transmission, the gain is reduced to 0. After the transmission takes place and the pulse has gone some distance, then it is brought back to normal gain जो आपने सेट कर रखा है। तो सिग्नल आती है, फिर यहाँ पे दी जाती है। उस समय तो स्टाइलस यहाँ होगा, ये वाली लाइन तब नहीं आएगी क्योंकि ट्रांसमिशन के समय रिसीवर वाज डाउन और गेन वाज लेस। सो यहाँ की वो लाइन जो प्रॉब्लम थी वो हट जाता है। द सिस्टम ऑफ इंक्रीजिंग और डिक्रीजिंग द गेन automatically is called swept gain control. This gain control is swept gain control. What it does is that it reduces the gain of the receiver during the transmission, and after transmission has taken place, the gain is brought back to normal. It happens with every pulse. For every pulse, जिस भी PRF से ट्रांसमिशन हो रही है डॉट 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 डॉट, तो वैसे ही उसी रेट से गेन भी कम ज्यादा हो रहा है। So that is what we call as cross noise. Next is aeration. 2 minutes for aeration. When the ship is moving, there is this transducer. When the water hits the hull, it creates lots of bubbles. The bubbles in front of the transducer, they stop the transmission. They produce resistance. They start reflecting some waves back. Matlab, the bubbles here do not allow the signal to pass through it. अगर जा भी रही है तो बहुत कमजोर सिग्नल जाएगी और रिटर्न में फिर से यहां से पास करना होगा, तो देयर मे बी प्रॉब्लम। Some bit of energy is also reflected back by these air bubbles. So again, very close to the transducer there is a reflecting surface. So on the recorder, what happens? Again, zero line के आसपास में there is recording because some signals are getting reflected back from the layer of bubbles itself. So what we can do? Keep it transducer as far away from the sources of bubbles. क्योंकि यहां तक आते आते बबल्स जो है वो पानी में ऊपर आ जाएंगे, खत्म होएंगे, तो there can be possibility of reducing this error by placing the transducer at the right place. But it does not happen all the way. So from bow, there are some distance like 1/4 to 1/8, or rather 1/8 to 1/4 LOA यहाँ के आसपास में ले दे के ठीक ठाक रिजल्ट मिल जाता है। So the transducer should be fitted at a place where there is least amount of bubbles. Also away from the sources of noise, other noise, इंजन रूप से दूर भी रखना है। Now suppose the ship is going astern. जहाज पीछे कैसे जाएगी? पानी को आगे धक्का मारेगा या नहीं?
Yes,
During
sir.
that, the propeller is rotating and it is churning the water. Near this, lot of air bubbles are produced. So much of churning water, producing so much of bubbles that nothing passes through this. No signal is going here. So if the depth is here, the depth is not readable. Since it is very close to this, there is a very heavy dark mark near the zero line. सब यहीं से वापिस हो रहा है. And there is no reading of the seabed. This happens especially when the ship is going stern, the water is being pushed towards the forward where there is transducer fitted. This particular problem is called aeration. Bubbles stopping or obstructing the signals is called aeration. Cross noise is that receiver is picking up the signals directly, not reflected, but directly coming from the transducer, transmitting transducer, causing dark mark near the zero line. But of course, the swept gain control takes care of that and it reduces the error, or rather cross noise. So we good on these accounts जो बात किया हमने.
Yes, sir. Yeah.
Any questions that you need to ask or you wish to ask? Any questions? हाँ भी नहीं बोलोगे, ना भी नहीं. So bye bye. Have a great day, all of you. गुड नाइट तो बोल दो.
थैंक यू सर.
ठीक है.
थैंक यू
हाँ,
सर.
तो कम से
Thank
कम
you, sir.
Thank you, sir.
हाँ, ये इतना बोल के कम से कम छुट्टी तो करो, हमारी भी अपनी भी. वो भी नहीं बोलोगे. चलो बाय बाय.
Thank
हैव
you,
अ
sir.
ग्रेट डे. साइनिंग ऑफ.
Bye, sir.
बाय 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 बाय. एक और अगले क्लास में कोशिश करेंगे कि ये खत्म कर दें, फिर एक दिन बच जाएगा सर. चलो टेक केयर. बाय बाय. साइनिंग ऑफ.
Thank you, sir.
थैंक यू सर.